A lot of questions on homework 10 in problem set 2, and I wanted to give you a couple clues for the setup. It can be kind of confusing, but it looks like the same basic problem that we've been doing, where we just get a system of a couple of unknowns and have to solve for it. Let's start our analysis, and the key is really to look at this system here, and we get a free choice of coordinate system. So I am going to pick my origin to be where the projectile launches. Now the x-coordinate here is parallel to the surface, so you can go ahead and set the angle in here to be equal to theta. Okay? And then what we want to do is figure out a little bit about the triangle that is going from launch point to where it hits. And this gives us this nice relationship here, because we know that if this is the origin, my x0, and this is my x final, and this is my y0, and up here is my y final, then I can use my kinematics equations to say something like this. So I can say that x is equal to x naught plus v naught x times t. And again, no acceleration in the projectile motion case. If I push the x naught to the other side, I get x minus x naught is equal to v naught x times t. Okay, so given that, what I can do is say that this is related to this property of the triangle, and it has related to the variable that I care about, because it is also d times the cosine of just theta, and that is equal to x minus x naught. And then the similar treatment we can apply for the y direction. So we can say that y is equal to y naught plus v naught y times t minus 1/2 gt squared. Given the projectile motion setup, we're going to push the y naught to the other side. We're going to get y minus y naught is equal to v naught y times t minus 1/2 gt squared. And finally, I can say that this y minus y naught, that is equal to also d sine theta. So I'm going to go ahead and say that that's equal to v naught y times t minus 1/2 gt squared. Now finally, I can make a kind of poke at what the initial velocities are. And that's just this initial velocity vector v naught, and the angle it makes with the horizontal is theta plus phi. So I can finally get open this, that v naught x is equal to v naught times the cosine, not just of theta like we usually have, but theta plus phi. And v naught y is going to be v naught times the sine of theta plus phi. Now, given all of this information, I finally have a full closed system of equations where I end up plugging these two in here, and I end up with two equations. That's these equations up here, in two unknowns, namely t and d. And I can eliminate t and solve for d, and that'll give me the answer that the problem, also known as me, is looking for.